who missed this, and I always feel like it's a shame they don't get to say, I know it's not the same, but all right, let's just go ahead and get started here. Do I show up in the frame?
Yes.
Oh, that's awesome. Okay.
Please tell me you're recording when he said that.
I know, it's okay. So basically, there's companies that out there, like the one I get my product from is called Airgas. And what they do is they basically take air, which is free, and then they put it in a cylinder, and they drop the temperature on it. And as you drop, as things get colder and colder, the atoms go slower and slower and slower, and the atoms get closer and closer and closer. And then, when they start to stick to each other and not bounce off each other anymore, they've gone from a gas state to they condense into a liquid, and they start oozing down the sides of this cylinder, and they turn into a puddle, and they just take that liquid and they put it in a bottle over here, and they say, hey, there's argon. We're going to sell it to the people who make windows. And they cool it down, and then there's a puddle of neon at the bottom, and they take the neon and they sell it to people who make neon lights. And then the oxygen comes down. There's this pretty blue liquid. It's oxygen. It's quite a bit of it because almost 20% of air is oxygen, and they sell it to medical supply companies. And then they cool it down, and you've got, and of course, different things. It's called fractional distillation. So basically, because every substance has a different temperature at which it melts and boils, and that's one of the things we're studying in this test, is they're able to use those differences in boiling points and melting points to separate these substances from each other, and then market them. And what they have the most of is actually nitrogen. What you breathe is air. Air is a mixture. But what surprises a lot of people is air is not mostly oxygen. Oxygen accounts for less than 1 molecule out of every 5 that goes into your lungs. 8 out of every 10 molecules that go into your lungs is nitrogen. You don't do anything with it. Just like a fish breathing water. What does the fish want out of the water? They want the oxygen that's dissolved in the water. They breathe water to extract the oxygen. You breathe air to extract the oxygen, similar to a fish. So basically, what's weird is this, though. So this company has this nitrogen, which is the bulk of what they produce, and nitrogen is mostly just used as a refrigerant. But they'll sell it pretty cheap. And when I say pretty cheap, this container here, this container is not pretty cheap. This is a really fancy container called a Dewar. Basically, it's a double-lined steel container, and it has this little thing here where they can hook up a vacuum pump, and they can pump most of the air out from inside the 2 containers. So you basically have steel, vacuum steel, and what that does is it slows down the rate at which energy can leak into this container. It just makes it a $500 thermos is what this is, called a Dewar. Okay, so I rent this from the company, and then they pour some liquid nitrogen in here, and I take that home, and that liquid nitrogen costs like $56. So $56 for 10 liters is not that expensive, and it's basically used for just doing gee-whizzy kind of stuff. Or sometimes in the electronics industry or the medical industry you might want to have it at that temperature. But here's the thing: how many of you ever had a wart burned off with it? I mean, nobody wants to say, I had a wart right here. Okay, all right, maybe you don't want to raise your hand. I'll raise my hand. I had a wart burned off with this stuff. And so some people say, I've heard of liquid nitrogen. That stuff is so cold, it's hot. But that doesn't make any sense. It's like saying, see that car over there? It's so slow, it's fast. It doesn't make any sense, okay? Here's why people say that. Because liquid nitrogen causes harm that's fairly similar to the harm caused by a burn, okay? And I'll come back to that in a second. But the point is, it's not hot. It's very, 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 very cold. So let's see. Here's a cooling curve. Is that showing up in there? Okay. So basically, here's 20 degrees, room temperature, right up here, right? If we cooled this room right here down, we all bundled up, and we started getting colder and colder and colder and colder, at a certain temperature, what we'd notice is, oh, I didn't even have that showing during that time. You didn't see that.
We didn't see it.
You didn't see it. Okay. So what happens is, as the temperature drops down, what is it right here? In this room, what is nitrogen? Hey, Melody, just have a seat. I'll get that from you later. Oh, I'm so glad you're here today. Right now, in this room, it is a what?
Gas.
It is a gas. All right, gas. Let's see. All right, the next one here. It's a gas. But at a certain point, I'll get cold enough, it plateaus, and what is it here? It's a liquid. Now, one of the things you've got to be clear on the test is this. What do you call that temperature where the transition between the gas state and the liquid state? What do we call that temperature? It's called the boiling point. And in this case, I'm not boiling it. I'm turning it from a gas to a liquid. Do you recall what that state change is called? Okay, condensation, condensing. And it happens at this temperature right here, which we call the boiling point. And for this temperature right here, for this particular substance, for air in this room, the temperature is negative 196 degrees Celsius. So we're all sitting here shivering. It's negative 197. We're just cold. Now it's negative 196, and we're like, look at all those droplets forming on the wall. Look at all that condensation on the wall. What is it that's condensing on the walls? It ain't water. What is it?
Nitrogen.
It's the nitrogen. All of a sudden, it just turns into a puddle on the floor, and it becomes a liquid. Someone comes in here in a spacesuit and goes, cool, liquid nitrogen, that's awesome. I'm going to pour it into ice cube trays and keep cooling the room down. And as they cool the room down, it will change from a liquid to a solid in a process called, you're out of kids?
We only have one and she's absent.
Oh my gosh, okay. Michaela, that's for you. They're making you go out in this harsh cold? I can't believe it. Hazardous duty pay. Okay. I'm sorry, what was this transition here, Beja? I didn't hear you, Beja. What did you say? When it changed from a liquid to a solid, it did what? No, it didn't condense. That's going from a gas to a liquid, silly girl. It went from a liquid. If you put liquid water in your freezer. Oh, yes, it's called freezing, okay? What do we call the point at which freezing occurs? And it's not called the freezing point. Yes, we're going to call it the melting point. Some books will call it the freezing point, okay? But we call it the melting point, or the MP. And the melting point of the stuff that you breathe, nitrogen, is negative 210 degrees Celsius. All right, so the point is you can take any substance, including air, and turn it to a liquid or turn it to a solid. And this company does that, and they sell the products. And I buy this product. Here's what's cool about this product is this. If you recall, you know what, let me just take some out here. Let's just look at some of it here. Let's see, it's just right here. Let's see. Let's pour this. Don't get that on film. Okay. This is so embarrassing.
Yeah, it is.
Epic fail. There it is. Okay. Ooh. Okay. I have no defense. It looks just like. Is that showing up on my video? Is it? That's so great. Boy, I hope this works. All right. It looks just like boiling water. Well, here's the thing. If I handed you a glass of water on a planet where the temperature is 1,000 degrees, what would the water do? It would boil. But what would be the temperature of the water as it was boiling? 100 degrees. The room's 1,000, but your boiling water would be a nice, cool 100 degrees. This room is 20 degrees. This stuff is a boiling liquid. It can't be any hotter than the boiling point. Think of the boiling point this way. The boiling point is the highest temperature at which the substance can exist as a liquid. The hottest temperature that nitrogen can exist at as a liquid, at least at 1 atmosphere pressure, is negative 196. That's as cold as the surface of Pluto, people. It's really, 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 really cold. And it stays cold for this very reason that, let's see, oh, here we go. Here's the container. I pour the liquid nitrogen into it. And what happens is, the room temperature outside is 20 degrees. The liquid nitrogen is at its boiling point of negative 196. And what happens is, everything will go from, including energy from high temperature to low temperature. Okay? And that's the second law of thermodynamics. It wants everything to be the same. As that energy flows in, this doesn't get hotter. What does it do instead of getting hotter? Well, it doesn't evaporate, it boils, okay? Bubbles start to form. And what's in those bubbles? In a pot of, a beaker of boiling nitrogen. Nitrogen. Nitrogen atoms that are getting together are going to be hotter than this. So yeah, these ones can be hotter than 196, but the liquid can be no more than 196. And that, my friends, is very, very, very cold. It's dangerously cold. It's so cold you can use it.
Great, this is good.
Wow, that's right!
He's focusing right on you. Just
That was evil, Charlie, that was evil. Okay. I regret to inform you there's a company called Alcor and a company called TransTime. Here's what they sell: a lie. They sell a lie because they know everyone's afraid of dying. So they say, hey man, you give us $1,000 a month, and I'm not making this up. There used to be 3 of these companies, now there's 2 of them. You give us $1,000 a month, and when you die, you're going to wear a bracelet. And it says, hey, if you find this guy dead, call 1-800-TRANS-TIME, and we'll fly out in our jet. Right? And we're going to pack you in dry ice. And we're going to fly you back to California. Of course, it's California. They're so weird. And we're going to put you in a baggie, and we're going to put you in a pot of liquid nitrogen, and we're going to keep you, because you know what? At this temperature, negative 196, nothing can rot. So you won't rot. And we can keep you there for 1 million years if that's what it takes. And sometime in the far, far future, 20,000 years from now, they're going to figure out how to fix whatever it was that killed you. We'll put you in the microwave, thaw you out, fix you up, and you'll live forever.
They do that?
I will? Sure, just give me $1,000 a month. Okay. My friend who manages my money, he has a client who did that for years and years and years. I read about this in a magazine. I couldn't believe it. And they said that there used to be 3 companies. One of them went out of business. Well, guess what? What is this nitrogen doing right now? It's boiling. If I promise I'm going to keep you in boiling nitrogen, that means I have to keep adding the nitrogen, right? But if I go out of business, what am I going to quit doing? And what's going to happen to the bodies? They're going to thaw out and turn to goo, which is exactly what happened. This investigative reporter said, hey, didn't that company, what happened to the bodies? And they went there, it's like all rusted gates where they go and there's nobody there, and there's this, this open container with like 10 rotting bodies in it because they ran out of money. Please don't give me money. But now there's 2 companies left, right? If you can't afford $1,000 a month to have your whole body frozen, guess what they'll freeze for $100?
Your brain?
Not just your brain, your head. And I saw the picture, and you look in this tank, and there's these baggies with like the heads of these people who weren't very smart with their money. It's like, first of all, do you really want to wake up 1,000 years from now and just be a head on a plate? Hey, wait!
We have Futurama.
Is that what happened in Futurama? Is it really?
Yes,
Oh,
they
okay.
have in Futurama. They have like little heads in jars.
And
They actually live. They talk too.
Oh, well, that's Futurama. I don't know. These people have a name for themselves. They call themselves Neros. The Neros are the people who have joined the Freeze My Head Club. Well, anyway, here's the problem with this. Here's why I don't want you to do this, because when you if you stick your finger into lava, it's bad for you. I think we all understand that, right? It's bad for you for this reason. Is that when you stick it in lava, your cells are bags of water. The water boils, and when it boils, it ruptures the cells. And when the cells ruptures, well, they're useless now, and then it's just going to turn to goo, and you have to cut it off. Okay? If you stick a can of water in the freezer, what does it do? It blows up because water expands when it freezes. And so your cells, all of them rupture. They might as well have been put in lava. If I stick my finger in here, I might as well stick it in lava. It does the same kind of damage. Stick my finger in here, and if it's unprotected, you're going to lose that hand. Look, I stuck a banana in here earlier. Look, I'll stick one in right now. Hang on a second. Yeah, Nate?
How come water expands when it freezes? Because the...
We talked about that earlier. I'll say real briefly. The water molecules have a right-hand bend to them. And normally the water molecules can just kind of do this, but when they freeze, they kind of open up into these 6-sided crystals that have this big open space in the middle. So, and that's why it floats, because it's less dense, because there's a lot of open space. This is what healthy banana looks like. Okay? This is healthy banana tissue. I'm going to stick it in here, and it's going to... Why is it suddenly boiling much faster?
Because the banana.
Cole? Go ahead, what?
Because the banana's hotter than the...
Yeah, it's like it's hotter than so it's making it boil fast. Just like taking red hot metal and sticking it into a bucket of water. It boils really fast. Now I know right now it looks like healthy banana, but look at these bananas from earlier. Does that look like happy banana tissue to you?
Absolutely.
This looks like fairly happy banana tissue. This looks like most unhappy banana tissue. This is you after they pull you out of liquid nitrogen 1 million years from now. I don't think you're going to be very... Every cell in your body will rupture. That's really kind of a... to me, not a very good sales point. But I say this, the thing is, if you have the appropriate... I'm going to cry is what I'm going to do. All right. If you have appropriate protection, though, which we just purchased this year, you can actually put your hands in stuff. Which for years I've been wanting us to get this, and they always go like, "Oh, Eric, we have other things to spend our budget on." But last year we had a little bit of surplus. I'm like, "Come on, guys! I always want to get these liquid nitrogen." Goes, "You only use it once a year." I said, "I don't care. I want it. I've been here for 25 years. I deserve it." Say, Barney, let me get these things. And they're awesome. And they're disposable, but they do work. It's really, really cool. It's this weird material. Let's see. I know,
Putting on the liquid nitrogen.
I'm not very coordinated. I don't understand that. I was never much of an athlete, if the truth be told. Surprise, surprise.
Charlie, you're
But-
so mean.
But here you go.
What is wrong with your finger?
You know what? I actually do feel a little bit. I thought I wasn't supposed to feel it. Feels downright cold. It actually hurts a little bit. What was that sound?
That's not actually his finger.
What? What? Oh no! This is terrible. This is the wrong glove. I gotta get this off. Oh, it's a hot dog. Somebody told you. I know that I could find them. I had a girl cry one time when I did this. I was so happy. She was.
That's so weird.
I was so pride. Okay. All right. Let me get rid of my finger here. All right. Actually, I have it. These gloves let me do it. Okay. But not, actually, I'm going to let my dice decide who. I am going to have somebody actually touch this stuff. But they're not going to get injured, I hope. And here's the deal. If you take this stuff and you, if I pour it across the table, look what it does. As it goes across the table, bring that up here. Bring the camera. I want to see this. Let's zoom in on this. Okay. Watch this. Okay, watch this. It goes like this. See that? It's like air hockey. Okay, you can go on back there. Okay. Now here's why it happens. Okay. It happens because. It happens because, for instance, if you've ever worked at like a church or a camp or something like that, where they have these big metal griddle cooking surfaces where you cook like a lot of burgers or pancakes. We have them here in our kitchens here, I believe. They have McDonald's when I work there. And the thing is, when you go to clean it, you pour water on it, and it does the same thing. And the reason it floats around like air hockey is because the surface is much hotter than the boiling point of the substance that's being put on it. So what happens is a droplet hits it, and as heat flows into it, it boils very rapidly, and it basically lifts it. Those are terrible. It lifts itself up. That's even worse.
Don't even drop it.
You didn't see that. It lifts itself up on a curtain. Man, I'm terrible at that. On a curtain of boiled vapor, and so it never actually comes into direct contact with the surface. So theoretically, I could pour this across somebody's hand, and they wouldn't actually come into contact with the liquid that's as cold as Pluto. Let's just see who the person's going to be. Oh, Trishana. Yes. That was a great look on your face. All right, here you go. It's okay. The odds of you losing your hand are very, very moderate. Okay, you're going to stand right over here.
Why do I have a feeling this isn't going to work?
You're going to tip your hand downwards. Open your fingers up.
You said
Okay, don't tip it quite that far. Okay, it's going to be fine. It's going to be fine. Here you go. Ready? Didn't feel a thing, did you? Okay, you can have a seat. And the reason is because you didn't actually come into physical contact with the stuff. If she'd gone like this, ooh, I want to see it, and let it puddle up in there, yeah, they had to like saw it off and put on a prosthetic, okay? Now, the sound it makes when it hits the floor, you hear that sound it makes when it hit the floor? Okay? It sounds very different on the table than it does on the floor. Look, on the table it's quiet, but listen to what happens when it hits the floor. That's the sound of little explosions, because if you think about this, in a liquid, the molecules are in physical contact with each other. Okay? So what happens is in a liquid, they're all rolling all over each other. Okay? In a gas, they bounce off each other. And you do need to know that for the test. The difference between a gas is the molecules do not remain in contact with each other. And in a liquid, they stay in contact with each other. It could be a new dance. Okay? In the 60s, they used to dance like that. Right? And I could do that. Okay? But anyway, but now watch this. I have a gas. Here's the molecules in the gas. I'm going to bring them together. As I squeeze these molecules closer and closer together, what's happening to the pressure of the gas? is doing what? It's increasing. And maximum pressure is when the molecules are touching. So what happens is I have a liquid that instantly it hits the floor and instantly turns into a gas, and the molecules are close together, so they fly apart from each other, and that makes a little explosion. Those little sounds you hear are little tiny uncontained explosions. And the reason it happens is instead of hitting a flat surface like this molecule is going to hit the carpet, and the carpet has all these like protrusions that cause that liquid to boil very, very rapidly. And we're going to do this. So I want you to just take a look right here at that red spot. If you can see that red spot, it's good. Okay. What I'm going to do is I'm just going to pour some of this on that red spot on the floor. And what I want you to see, is this. It's like a blast wave that comes off it, which is kind of cool. This ring of smoke goes flying away from it, which I think looks awesome. Can you see my red dot?
Yes.
All right. Yeah, you can put your hands there if you want. You can put your toes there if you want. It won't hurt. And put your hand down so you can feel the blast, the cold wave go by. Okay, here goes the cold wave. Oh, that wasn't enough. All right. Wait a second. If some is good,
More is better.
more is better.
Holy, oh my God.
No. All right, we got the hands down there now.
What could
Too
possibly
close.
go
I
wrong?
don't want anybody losing fingers here. Come on now. All right, here goes.
Miles, you smell good.
Whoa.
Is it cold when it goes by?
Oh, yeah.
Yeah, let's do it one more time. All right.
All right.
Now, when you look at it, look at this frostiness. Do you see this frostiness on it? What do you think this frosty substance is? Good thinking, but it's not. I heard, what is it? I heard a W word.
Water.
It's actually water, but it's not condensated, because condensation means it's gone from a gas to a liquid. This is sublimated. It went straight from a gas to a solid state. And if you watch carefully, I don't know if you can see it from where you are, but you can actually see the crystals disappear before they hit the floor. It's like it's snowing, but it goes away before it gets to the floor. Yes, go ahead.
So is there a transition directly between solid and gas?
Yeah, sublimation.
Well, I mean,
Is there a point?
I mean, is it the same? Is it called the same way going both?
Yes. Some books will refer to it as reverse sublimation. I know now most of them just refer to as sublimation in both directions. I don't know. All right, now, but where did this water come from? These water molecules were not inside that container. That has nothing but nitrogen. Where did this water come from? In the air. If I was doing this in a desert environment like the Atacama Desert of Chile or the Gobi Desert, there wouldn't be any of this because there wouldn't be any atmospheric water vapor. So in fact, when you look at liquid nitrogen and you see all the steaminess stuff, this is not nitrogen. This is very cold air, and when it passes through the air and cools it down, it causes water vapor to form basically a cloud. All right? Now, so all this misty stuff you see here, that's actually atmospheric water vapor. If we were doing this in a very dry room like maybe Arizona, we wouldn't see any of this. Now, we talked about volatility before. I have some water. Water is a volatile substance. What does that tell us about water?
Vaporate. Does that vaporate?
It vaporates. It vaporates. Okay. It evaporates. Okay. Or vaporates if you're Canadian. Okay. And so as it's vaporating, I like that word. As it's vaporating, it vaporates one molecule at a time. How come I don't see it happening?
Because it's not boiling.
No. Why don't I see one molecule at a time?
Because it's smaller than a light thing.
Say it again.
Smaller than a light thing.
A light thing. Light bulb?
No.
Smaller than light bulb? Miles?
Light waves.
Smaller than light waves. Okay, so it's smaller than light waves, and so you can see it. But groups of water molecules are bigger than light waves, and so basically when you see this stuff here, oh, that was dumb. Ooh. So stupid. you didn't see that. When you see this here, it's just these are little droplets that have condensed. Okay, so but here's the thing: this is basically what you have in the room, but there's a whole bunch of it jumping out here. So if I pour some liquid nitrogen here and make this water, the air around this water very cold, I'll be able to see all the molecules that are vaporating out of there, that are evaporating out of there. Here they are. Maybe some of you have seen something like this at your house on Halloween.
Yes.
You did? How did you make it happen on Halloween?
Fog machine.
Well, there's fog machines. There's another way of doing it. Yes, go ahead.
Dried ice?
Dry ice. Dry ice. A lot of people say, oh, look, it's the carbon dioxide. No, it's not. The carbon dioxide, the dry ice, is at like negative 56 Celsius. And that makes the air so cold, it causes the water vapor to condense into a cloud. If I took something that had much less volatility. Now, if you remember the volatility lab, what was the substance that had the least volatility? Kerosene, okay? It had much less volatility. In fact, I don't know if any of them might have been volatile at all, hardly. Watch this. Would I expect to see more or less cloud? Less. There's hardly any cloud coming out of it. That's just the same as what we have in the room. If you compare that, compare that to the
bubble of
compare that to the water, there's a lot less of it in here, right? Now, there's a substance that we looked at that was much more volatile. What was the most volatile substance we looked at in that lab? Methanol. So let's try that. Here's some methanol. And this is awesome. Whoa. Yes. All right. Now, what is this stuff here? No, it ain't water.
Methanol.
It's methanol, which is flammable, by the way. It's a flammable cloud. No, I won't. Not until I get my awesome, dangerous science TV show that I want so bad. And then I'll do it, okay?
Why do you bring up
I have like insurance for this kind of stuff.
Go outside and do it on fire.
No, not even then. No, I do have my limits, sadly. Right, now,
I'll do it.
no, though,
Give me a lighter.
I have a saying, if some is good,
More is better.
Oh,
This will be interesting.
Charlie, come back.
Oh my goodness.
I'm staying.
Is that all methanol in there?
No, this is water. Actually. Okay, sorry. Now, here's the thing, okay? Now, these bubbles are more or less dense than air. I'm hearing more and I'm hearing less. Who's right? They're more dense, that's why they're sinking. But if I had dragon breath, very hot air, right? What does hot air do? Right, because of convection, which we stated, okay? Now, the thing is, you just have to be hotter than your environment. If I was to go to Pluto, which is the same temperature as liquid nitrogen, and I would have dragon breath on Pluto, which would be a good name for a book, Dragon Breath on Pluto. What would it do you think, on Pluto? I know, so here, let's try. Let's just try. You ready? Let there be Pluto.
Oh, there's gonna take
our hand is.
Now, wait. Let's go. Come on. Yes.
They're like bouncing off the side.
Oh, badoing. Oh, yeah. Look at that. Look at that.
Weird.
Why does it sink, do you think?
Do bubbles freeze?
Because they get cold.
They get cold, exactly. All right, let's continue on. It's time to play a very fun game called Solid, Liquid, or Gas. You're going to love this game. You had to play this game on the test that's coming up. Here's how it works. I'm going to give you melting point, boiling point data. Okay? Melting point, boiling point. Now remember, the way you approach this is think of it like a number line. Hot, cold. Okay? Absolute zero down here. Now I've done you a favor over past years. Past years I had it in degrees Celsius and they're negative numbers which were confusing. This year I decided to do you a favor. I converted them to kelvins. And how did I convert the Celsius to kelvins?
273.
I added 273, okay? And so here you go. The idea is, that if you're below the melting point, are you a solid, liquid, or gas?
Solid.
solid. Okay, said without confidence. If you melt and get above the melting point, you become a
Liquid.
yes. And if you are heated and you boil and go above your boiling point, you are a
Gas.
Great. So here's the question. Carbon dioxide is going to be immersed in liquid nitrogen, which is at a temperature of 77 kelvins. I'm going to lower the temperature to 77 kelvins. I want to know, and don't blur it out, I'm going to have my dice decide, is carbon dioxide going to be a solid, liquid, or gas at 77 kelvins? Decide now while the dice decide who talks to me. Okay, she's not here, so I have to roll again. And William!
Solid.
I agree, because 77 kelvins puts you well below 217 into the solid range. We have a name for solid carbon dioxide, we call it dry ice. And the reason it's a dry ice is, look, it can't exist, at least at normal atmospheric pressure, it can't exist as a gas. It transitions directly from solid to gas in a transition we call sublimation. Now here's what we're going to do. It's kind of freaky watching stuff sublimate because our brains are so programmed to thinking if you can't see something, it doesn't exist, and that's weird. So what I'm going to do is this. I'm going to take this old school projector. I'm going to shine it up here, and I'm going to dump the carbon dioxide crystals on here, and you're just going to pick one and watch it sublimate away. And it's really kind of fun to do. So let's just try this here. Let's see. I need some more. So I'm going to need some things here. I'm going to need some liquid nitrogen. I'm going to need a bag of carbon dioxide. Warning, this can be a little bit loud sometimes. I'll try not to do it loudly, but if it is, I'm apologizing in advance. So here I have a baggie of carbon dioxide. And I'm at 20 degrees Celsius. As I cool it down to to 77 kelvins, I'll drop below this melting point and it will turn into a solid. All right, let's watch this happen. You already see white on there, right? Those are crystals of carbon dioxide, but let's just turn them all on. Let's turn the whole bag into solid. And by the way, my commitment to Hawaiian Shirt Friday, I gotta say, this morning, I had to really be committed. I had to open up my ski drawer, take out my base layer. But I'm telling you, the day is going to come before I die when the whole world is united for Hawaiian Shirt Friday. All right, see the powder in the bottom there? All right, that's solid carbon dioxide, aka dry ice. I'm going to just shine it on the board, and all I want you to do is pick one little piece of it and watch it go away. Just pick one little piece of it and watch it go away. I'm picking this piece right here. Bye-bye. Where are they now? Invisible. You're breathing them in. I'm breathing in chemicals. Yes, you are. All right, now, that was fun. That was so much fun. That's what I like to do on a Friday night. Watch crystals sublimate. We're going to play again. This time we're going to play the game, solid, liquid, or gas, but we're going to play it with oxygen. So look, here's the data on oxygen. Boiling point, 91 Kelvin. Melting point, 55 kelvins. Temperature I'm cooling it to, 77 kelvins. And I want to know, is it going to be a solid, liquid, or gas? And I'm going to roll the dice of doom, and they are going to choose a person named Beja. Beja, you can do this. Well, here's the question I'll tell you again. Is it going to be a solid, a liquid, or gas? Oxygen. I'm cooling down to 77 kelvins. It has a boiling point of 91, a melting point of 55, and I'm cooling it to 77. What's it going to be? A liquid. Have y'all ever heard of liquid oxygen? Have you ever been to the town of Sequim? There's this town up near Port Angeles called Sequim. Everybody, I think the minimum age to live there is like 100. And you go into a diner and everyone's walking around with oxygen up their nose, okay? Because liquid oxygen is used by people who need to have extra oxygen. Their lungs aren't working so well, right? Well, why carry it as a liquid? Because in a liquid, the molecules are as close together as they can get. When you go to outer space, guess what they don't have for you up there? Oxygen, so you better carry it with you. So they carry liquid oxygen in outer space. That's why, if you look at a NASA launch before it takes off, have you ever noticed the steaminess pouring down the side of the space launch vehicle? That's because you can't cap this, because it's a boiling liquid, and it'll explode if you do. In fact, Apollo 13, I imagine a lot of you saw the movie Apollo 13.
Yeah.
Okay, here's what happened on Apollo 13. You watch it again, you'll see. Here's what happened. They said, yes, we're getting ready to stir the liquid oxygen. They had to stir the liquid oxygen because in space it's super cold. And when it turns away from the sun, the temperature drops close to absolute zero, and they're worried that their oxygen is going to freeze. So they stirred it to try to make sure that it stayed at a uniform temperature that was above that, okay? But when they did, unfortunately, the pressure built up, and that's what made it explode. But the bottom line is, you carry liquid oxygen in space. So I'm going to make some liquid oxygen. And now, there are some misconceptions about oxygen, about high oxygen environment, pure oxygen environments. I've seen many TV shows misrepresent what happens. Have you ever seen like a TV show or a movie where somebody like is in an oxygen tent and they light a cigarette or a cigar or something like that? You ever seen that?
Yeah.
What happens?
It explodes.
It explodes. And this is very inaccurate. And the reason it's inaccurate is that oxygen doesn't have any chemical energy in it. It releases the chemical energy that's in something else. So like a candle or cigar has chemical energy in it, but every molecule that hits it helps release it, every oxygen molecule. Well, in the room right now, only 1 out of 5 molecules is oxygen. If you have a pure oxygen environment, then 5 out of 5. So basically you can increase the rate 5-fold. So it burns faster, but that doesn't necessarily make it explode, as you'll soon see. So here's my candle. You know what? I could sing happy birthday over and over and over again before this candle burned all the way away. But what I'm going to do this time is, I'm going to get a bag full of oxygen. Now, I love liquid oxygen. I'm not even ashamed to say something that nerdy. I love it because it's pretty. It's a pretty pale blue color. Watch this. Now, actually, Shoshana, I need to get ready with the lights, okay? Oh, I'm sorry, Spencer. Is that your job? Are you? Oh, I'm sorry. I don't want to take Mr. Wilson's job away from him. All right.
So does oxygen have a higher boil point than nitrogen?
Yes. Do you see this pretty pale blue liquid down here? Look how pretty it is. It's so pretty. All right, turn out the lights. Now I'm going to sing a very rapid happy birthday song. Happy birthday to you, happy birthday to you, happy birthday liquid oxygen, happy birthday to you. Whoa. Hey, it didn't explode at all.
What if it just exploded?
But it sure is giving me bright spots in my eyes. I don't know about you.
So if you lit a cigar and you basically be done with it.
Yeah, you just had to smoke your cigar really fast. You shouldn't smoke cigars. A, it's smoking. B, it's a cigar. They stink. Okay? Now, okay. We're going to play it one more time. Solid, liquid, or gas. It's a fun game. It's the game that's sweeping the nation. Everybody loves it. They tune in every Friday night. Helium! This week it's helium! I'm going to cool helium to 77 kelvins. Its boiling point, 5 kelvins. Its melting point, 1 Kelvin. It's barely above absolute zero when it freezes. And even then, it only happens if you increase the pressure. Helium. I'm cooling it to 77 kelvins, and I want someone to tell me, is it going to be a solid, a liquid, or a gas? And I can't believe it chose this row. Oh, I got it backwards. It's row 3. Okay. Well, Charlie, that's you, cameraman. What's it going to be? 77 kelvins. Here you go. Here's the data. Solid, liquid, or gas?
Liquid.
It had to be between 1 and 5. Try
Gas.
again.
Gas.
Gas. Because 77 is well above the boiling point, okay? Now, so why would I bother to do that? because it illustrates a great thing called Charles' Law. You recall Charles' Law? If the temperature goes down, what's the volume going to do? It should go down as well. Now, that means the atoms have to get closer together, and what does that do to density? And the reason we like helium is because of its low density. That's what makes it float. It's what makes our voice sound silly, even though you're not supposed to breathe in it. Watch what happens. I'm not going to pop it yet. Watch. Aw, it turned into a raisin.
Yeah, you should have looked at it the entire time you moved it.
Now watch this. This is great. Aw. Believe in yourself, balloon. You can do it. Just believe in your dreams and they'll come true. I can fly. I can fly. Yeah. Well, now let's think about this. What if we put a balloon of... You're all ready to go. I think you know what's coming. Okay. All right. If I put a balloon in here, temperature down, volume. Then temperature, when the temperature goes up, the volume. That sound, I once had a nightmare after liquid nitrogen day where they took my, an evil scientist took my brain out and put it in a jar, and they put me in liquid nitrogen, and I made that noise as I sunk to the bottom. It didn't pop. You know why? Because when the temperature went up, the volume went up. But what if I put it in a jar? The volume couldn't go up in a jar, and the temperature goes up and the volume can't go up. What's going to go up instead? The balloon. The balloon. That's good. Because what's going to go up? Huh? The pressure. Let's just try this. That was fun. I tried doing this morning with my shoulder arm, the operated arm, and I was like, ah! So the balloon had its revenge.
Better.
If some is good.
More is better.
Okay, here we go.
You ever want to have the clown spin in that car at the fair? There's a trick. Auntie M, there's no place like home.
Can you put it in the jar and then put the jar upside
After you
down?
did that in there.
Alright, now. Alright. Temperature down, volume down, temperature up. Temperature up. The volume will go up, right? It's stuck together. Unless, of course, you put it in something.
Oh no. Here we go.
Maybe they'll all escape today. I think they will. Maybe.
Oh, there goes one.
Get a lighter.
No.
He really wants as soon as he put his
Ah! Victory. If some is good, more is better.
Please put Barney in there.
Put in Barney. Put in.
All right, people. I hope you're ready for absolute mayhem. Okay.
Oh man, I thought it was gonna pick up Barney.
Man,
This
this is
is
a
duct tape.
terrible idea I'm having. Just a terrible idea. A wonderful, naughty, awful idea. I haven't watched it yet this year. I've got to watch it. They're selling it at Safeway. I've got to buy it. I don't own the Grinch. How is that possible? All right, that should work. All right, this is a nice, high-quality balloon here.
This is bad. This is bad. This is bad.
Oh, I'm out of here. Charlie, don't lose sight of it, Charlie. That is one nut. Oh my God!
Oh,
Look at
Can I
it.
have that?
It looks like one of those like wigs. Look at it. But now, when you say you're going to liquid nitrogen, the first thing people want to know is what are you going to freeze?
It matches your shirt.
And it's true. It would be a crime to do a liquid nitrogen demonstration day without freezing some stuff. And really what it is that people like about freezing is that it causes the object to lose elasticity. So, for instance, balloons are elastic. That's why we can shoot them at people, and that's why they do what they do. Did I say balloons? Rubber balloons. Oh, balloons as well, right? But my stick that's underneath here, I find matter behaves very different at what are called cryonic temperatures. Yep. Hi. How are you? How's my breath? I'll floss next time. Let's see.
Barney.
Yeah, okay. You know what? Wow. Whoops. Flowers. Flowers and mushrooms. Oh my. Now you know,
You get the flowers and mushrooms off the programs, don't you?
the thing about flowers is, they're normally quite elastic. They're made out of water, all this cellular tissue. But did anybody go out last night walking around in your yard by any chance and step on grass?
Oh, yeah.
Freezing.
It broke. The grass broke when I stepped on it last night. Kind of the way this flower that looks fine right now will break. Like that. Oh, wait. Have you heard of a Caesar salad? I've invented a thing called the Samson salad. And it's like one of those California cuisines or sushi where half of it's in the presentation. It's the sound of it when it hits your plate, the sound of that shattering, ice-cold lettuce on a hot California day. Listen to the sound, iceberg lettuce, listen to it. Oh, the only problem is right now, it hurts to eat. It's actually the mushroom, here's the thing with the mushroom. I don't eat mushrooms. Now, I'm sorry if your parents get mad at me for saying this, but I've got to speak my mind. A mushroom is a fungus, and so is athlete's foot. Okay? I rest my case. I think that's a pretty solid case. I have it here for target practice. Watch this.
Oh, yeah. That's the one thing he can ever draw as Barney.
Hey! I think I do pretty good airplanes, too.
Except for Barney's art.
All right.
Why not drop?
Charlie, keep your eye on the Barney. Here he goes. Barney is
This
mine.
is so worth staying.
Oh, I missed him! No!
If you let me do it, I would have hit him.
Have a good weekend, everybody. Thank you.